Hi guys, good evening. So today we'll start with the layer 2 security features. And before going with the layer 2 security features, we will see about one concept, which is inter-VLAN routing. Inter-VLAN routing. Now, what is inter-VLAN routing? Inter-VLAN routing is all about providing communication between different VLANs. Okay, we know by default two VLANs will not communicate, right? So if you want to provide communication between different VLANs, you will use inter-VLAN routing. Now, to configure inter-VLAN routing, there can be few ways. Okay, the first way is you will use a router with separate interfaces. Two VLANs means two different networks, right? And for communication between two different networks, you need wheel router, layer 3 device. Okay, so this is the first way. Now here what will happen? You have a switch. With this switch, let's say you have connected two PCs. Okay, and these two PCs, they are connected like this. Switch PC1, PC. Let's say PC1 has an IP address 10.1.1.10, and this guy has an IP address 10.2.2.20. And this is connected to your F0 by 1 interface, and this is F0 by 2 interface. This is how they are connected. So if you want to keep them in the different VLANs, so let's consider this port will be in VLAN 10. This will be in the VLAN 10, and this side it will be in the VLAN 20. Correct? Now what I want communication between these two different networks. So I'll need a router, and my PC also for communication between different network, it will require a gateway. Gateway IP address will be required. So what I'll do here, I'll use a router. Okay. And from this router, I will use two interfaces because how many gateways will I require? Two. Okay. So I'll use two interfaces from the router. So consider this is my Z0 by 0 interface, and this is Z0 by 1 interface. This will be my router. So let's say gateway for this network I want to keep is 10.1.1.1, and here I want to keep 10.2.2.1. This is clear. And if I talk about the switch interface, so this switch interface will be, let's say, F0 by 3. And this interface will be in F0 by 4. This is clear. Now, by default, these 3 and 4, they will be in different VLANs. Like default VLAN 1, F0 by 3 and F0 by 4 will be member of VLAN 1. And this is VLAN 10. So VLAN 10 will not communicate with VLAN 1. So what you have to do, you just have to go and configure this interface in which VLAN? This in the 10 and this side 20. Now they are in the same VLAN. So my PC1 will communicate with this IP, PC2 will communicate with this IP. And since these networks are already connected to the router, router will provide the communication. This is your inter-VLAN router. That means there is no special configuration you need. All you need is F0 by 1 and 3 in one VLAN, F0 by 2 and 4 in one VLAN. This is clear. Now let's quickly see in the last. And as for each VLAN, we are using separate interface from the router. That's why it is known as router with separate interfaces. So what I'll do here, I'll take a router. I'll take one switch. And I'll take two PCs. PC1 and PC. Same thing I'll do here. F0 by 1 to PC1, F0 by 2 to PC2. Then I'll connect two interfaces, Z0 by 0, which is connected to F0 by 3, and Z0 by 1, which is connected to F0 by 4. Because I need two gateways, right? I have two different networks, so I require two gateways here. Okay. So this side, they will be in one VLAN, and this side, they will be in another VLAN. So here IP address I'll configure 10.1.1.10. Here I'll configure 10.2.2.10. This port VLAN 10. This port VLAN 20. Same way F0 by 3, in which VLAN I'll keep 10, and F0 by 4 20. Then here on the Z0 by 0 interface, I'll use the IP address 10.1.1.1, Z0 by 1 interface 10.2.2.1. Let's go and configure. Ten 1.1.10. 10.1.1.1. Ten 2.2.10. This is 20. Clear? Any doubts so far? Let's go and configure the router. Interface gig 0/0, IP address, no shutdown. Interface gig 0/1, no shutdown. Router configuration is done. Now all we need to configure is what? These interfaces 0/1 and 0/3, VLAN 10, 0/2 and 4, 20. Okay. So I'll say interface range F0/1 and F0/3. Switchboard access VLAN 10. Interface range F0/2 and F0/VLAN. Done. Now my PC1 should have communication with PC2. First packet will fail due to up, then we will have communication. So this time two different VLANs are communicating. This is first way. Okay. So right now what I did, I used separate interfaces for each VLAN, right? But imagine my network has 100 VLANs. Now what? I don't have 100 interfaces on the router, and I cannot go and purchase multiple routers also just for providing communication between the VLANs. So I'll use another method, which is known as router on a stick. This is the second method. So in this method, what will happen? Rather than using individual interface for each VLAN, we will use one single interface for all the VLANs. Okay. So this time your topology will be something like you will have a router, switch, and then you have your PCs. One link from here. And this is your switch. This is F0/1 interface. F0/2 interface. PC1, PC2. Same sort of IPs we will have. 10.1.1.10, 10.2.2.20. Okay. This is your router, and this is the 0/0 interface of the router. And this is F0/3 interface of your switch. So this interface again, this will be in VLAN 10. And this will be in the VLAN. Now different VLANs will not communicate. And here router is supposed to provide the communication. So that means through this F0/3 interface, through one interface, both VLAN traffic will pass. So what we have to do with this interface? We have to make it trunk. Because by default, it will be access port, and access port member of single VLAN does not forward traffic for different VLAN, right? So if you want to forward that multiple VLAN traffic, what you will do? You will make it a trunk port. So that means here I'll configure what? This is clear, but still the problem is I have two different networks. How do I configure two IP addresses on a single interface? Okay. So what you will be doing here, you will be breaking down this interface into small like parts, logical parts. Okay. So like one network, you break down into smaller parts. You call it a sub network. Subnetting we studied, right? You divide a large network into smaller network, right? So same thing, an interface will be broken down. It will be known as sub interface. Okay. So here basically we have to create what? Sub interfaces. So I'll break down this interface into multiple interfaces. How? I'll say z0 by 0 dot 10. This will be one sub interface, and another sub interface will be z0 by 0 dot 20. You can use any number after dot. From 0 to, there is a very big range. Okay. So you can use any number, your choice. I'll be using 10 and 20 so that we can say 10 is part of VLAN 10 and 20 is part of VLAN 20. Okay. Now, since this is a trunk interface, so this trunk interface will be putting up a tag. By default, they use the .1q protocol for putting the tag, and it will be putting a tab. So how router will understand that, okay, which interface will uh, hold the traffic of which VLAN. So that tagging also we have to tell the router. So here I will tell the router that you have to use what? .1q protocol, and you have to handle the traffic for VLAN 10. Same way here I will say that you have to use the .1q protocol and you have to handle the traffic for VLAN 20. And then we are good to go. Is that clear? So how you will do this? How you are going to configure this? See here. So what I'll do, I'll just go and copy this much part. Same PC1, PC2. Okay. On the switch, does it have the configuration? Now let me switch. I'll take a fresh switch. This is F0 by 1. That's correct. Okay. So same PCs are there, and you can see we have the IP addresses already available here. 10.1.1.10, and the gateway IP is also there. Same way. Here we have 10.2.2.20, and the gateway IP is already there. So PCs are configured. Switch I have taken new, so there is no configuration available on the switch. Okay, switch does not have any VLAN and any configuration. Then I'll be using one router. Okay. Now what we'll be doing, this interface VLAN 10, this interface VLAN 20, and this interface will be trunk. This is clear. And this interface, I have to create what? Sub interfaces. So now understand how I will configure the sub interfaces. PCs are configured. First of all, on the switch, I'll go and configure F0 by 1, VLAN 10, F0 by 2, VLAN 20, and F0 by 3, trunk. Interface F0 by 1, switch code access VLAN 10. Interface F0 by 2, switch code access VLAN 20. Interface F0 by 3, switch code mode trunk. Done. No, here native VLAN will not work. Native VLAN will be required when you have two different switches. Okay. Now go to the router. To understand the steps here, first of all, you will go to your physical interface, G0 by 0, which is your actual interface. So you say interface G0/0 and you will bring it up. No shutdown command you have to give on this interface. Once you are done with this, now you can go and create sub interfaces. Okay. So see here, if I say interface G0/0 dot, and if I see how many sub interfaces I can create, so I have a use range. Okay. So first one I will create 10. Now I have to tell the interface that, okay, for which VLAN you will be handling the traffic, and the protocol that will be there is .1q. So I'll give a comment here, encapsulation .1q, and you will handle the traffic for VLAN 10. And now I will assign the IP address. IP address 10.1.1.1. Done. We don't need to give the no shutdown command because this is a logical interface will be already up. Why it will be up? Because we have already brought up the physical interface. If you will not bring the physical interface up, they will never come up. Okay. Then interface G0/0.20, same command. Encapsulation is .1q and traffic for VLAN 10, 20. So then you will say IP address. No shutdown. No shutdown is not required. Once this is done, you are good to go because we have already configured this interface trunk, this in 10, this in 20. Now you can check the communication between PC1 and PC2. Again, first packet will fail due to up, then we will have communication. Okay. So this is the second method. So in the second method, what have we done? As a part of configuration, what we have done here? Interface 0/0, no shut. Then interface Z0/0.10. You gave the encapsulation, which is .1q, traffic for VLAN 10. You assign the IP address. 255.255.255.0. Okay. Anything for 20? That's it. IP address. This is done. This is only the special configuration you require. Other than that, this is trunk, this is VLAN 10, this is VLAN 20. Clear? Now, if you don't want to use a router, in that case, you can go with the third method. You can use a layer 3 switch. Okay. So what you'll be doing, you'll be using a L3 switch here. And this L3 switch will be responsible for providing communication. Here we don't need any router or anything else. Look-wise, it will be same only. Functions will be different. Different in case that it will have features of a switch, but also it will have capabilities of a router. Otherwise, it will look the same only. This is F0/2. Again, this is PC1, PC2. Time to 20. This is your L3 switch. Now here also you'll do the same thing only. This will put this port in the VLAN 10 and this side VLAN 10. Okay. Here what you have to do is you have to create switch virtual interfaces. In short, we call it as a SVI, switch virtual interface. That means you will put these ports in the VLANs, VLAN 10 and 20. Then you will create VLAN interface, interface VLAN 10, interface VLAN 20. To those interfaces, you will assign the gateway IP address. That's it. Okay. So your configurational part will be in the switch. First of all, interface, you will say F0 by 1. You will say switch port access VLAN 10. Interface F0 by 2. You will say switch port access VLAN 20. Then you will say interface VLAN 10 and you will assign the gateway IP address. IP address 10.1.1.255.255.255.0. Okay, and these are logical interfaces will be already up. Interface VLAN 20. You will say IP address. And then see what your router will do, forward traffic from one interface to another interface. That means router perform routing. So here also we have to enable routing. How? By using the command IP routing. That's it. This is all the configuration you have to do. Clear? So let's go and check it. These are again our PC. Now this time what I'll use a layer 3 switch. So you can use this 3560. In packet tracer, we have one switch here, 3560, which will say multi-layer switch. So you can change the name also. You can call it L3 switch. Connect here, F0 by 1, F0 by 2. Now similar setup configuration we can do. So you can see this switch will have router commands also. First of all, initially only you can see here that it is having what system configuration dialog. Normally switches will not have. Okay, but if you see here, it is asking about initial configuration dialog. We have set. Now enable, and you can see I can say like to IP route. It works here. Okay. Go to global configuration mode. You can say IP route also. You can say router, OSPF, all those commands, everything goes. So now what I'll do, I'll just put the port F0 by 1 in 10. So I'll say interface F0 by 1 with port access VLAN 10. Interface F0 by 2 with port access VLAN 20. Interface VLAN 10. IP address. No shutdown is not required. This is a logical interface. Already you can see this is up. Then you will say interface VLAN 20 and this IP address will be 2.2 and I will say what? IP. That's it. Now go and check this. Ping n.2.2. So I will have communication. Again, first packet will drop, our process, and then you have communication. Clear? This is how you can provide communication between different VLANs. Any doubt in this part? You don't have very special configurations. Logically, you have to understand the concept. Okay, clear? So today we'll go with these kind of small concepts only. And this was one concept. Now, another one is DHCP relay agent. Now, what is DHCP relay agent? Normally, when we studied about DHCP, why DHCP is used? Why DHCP is used? Assign IP addresses automatically. And there was a process that is known as DORA process. Okay, so how our network architecture was that time? We had a router which was acting as a DHCP server. I had a switch, and then I had clients who were receiving IP address. Right? This was the scenario. Now, earlier, what was happening that when my PC wanted IP from the DHCP server, my PC generated first message was, what was the first message in the DORA process? Discover message, right? And the discover message is a broadcast, correct? All those messages, because PC is not having an IP address, it was a broadcast. Since router was in the same network, we were able to have the communication. But what if you have a different server? Your DHCP server is available in a different network. In that scenario, what? This is my DHCP server, and this is not available in the same network. In this scenario, when my client will try to send, a broadcast message, broadcast will come here. Will it go here? It will not go. Why? Each interface of router is in a different broadcast domain, and a broadcast message will never leave a broadcast domain. That means my discover message will never come here to the server. I'll never get the IP address. Okay. So in this kind of scenario, this router, we have to configure it as a relay agent. What router will do? This broadcast message router will send to the server. Server will make an offer, that router will forward here. Then request message router will forward here. Then acknowledgement will come. So in between, router is acting as a relay, who is sending the information from client to server, server to client. Okay. All right. So let's consider the networks and all. This side, I'll be using the network 10.1.1.0/24. And on the router, I'll be configuring 10.1.1.1. This side, I'll use the network 10.0/24. On the server, I'll use the IP address 10.100. And on the router, I'll use 10.1. Clear? This is how our architecture is going to be. This is our network setup. So here, this router, we will configure it as a relay agent. Okay. So why your DHCP relay agent is used? It is used when the DHCP server is available in different network. When DHCP server is not available on the same network, you need a relay agent. And you don't have very special configuration. All you have to do, you have to go to the client side interface of the router And here you have to configure a command interface and 0 by 0. And here you have to configure one command only, which is IP helper address. And you have to configure here DHCP server IP address. Okay, and this is your client side interface. Clear? So my clients are connected on this side, right? So Z 0 by 0, and here I'll configure IP helper address and I'll give the IP address of the server. Clear? Only one line configuration. Now let's go and see this thing. These concepts, these are more of understanding, less of configuration. Okay. So let me go to the PC. These PCs, they'll get the IP from the DHCP server. So all I need to configure is router and DHCP server. Go to the server, desktop IP configuration. .1. Then I'll go to the services, DHCP, and DHCP I will configure for this network. So for this network, the default gateway will be 10.1.1.1 and IP address 8.8.8.8. Here 10.1. That is a Google DNS. We generally use it. Even if you don't use it, totally fine. Okay. Now let's say my DHCP server will start signing IP address from 21. Okay, some addresses I'm reserving. Save it, turn on the DHCP server. And just close it. DHCP configuration is done. I need to configure the router. CLI. So ignore, enable, configuration terminal, interface gig 0/0, IP address 10.1.1.255.255.255.0. No shutdown. Interface gig 0/1, IP address 10.1. Now, right now, everything is configured. I haven't configured the relay. So when these guys, they will try to take an IP address, they will not get an IP address. The DHCP will fail and they will get a APIPA IP address. So what is APIPA? Okay. What is APIPA? Stands for automatic private IP address. Okay. When a DHCP server is not available in the network or DHCP IP address assignment fails, a Windows PC will automatically assign itself an IP address. Okay, and that IP address we call it as a APICA. And from which network it will assign the IP address? The network will be 169.254.0.0/16. Okay, so that means if I talk about the APIPA IP range, so it will be 169.254.0.0. Okay, so now you can go and check here. From this range only, you have the IP address 169.240.254.82.77. Clear? But you can see right now I'm not getting a IP address. Right? And as soon as I'll go here on the router and I'll go to my client side interface and I'll say IP helper address and my server IP is 10.100. Now you'll see I got the IP address. My IP address is 21 now. So this time I got an IP address from the DHCP. Why? Because my router was forwarding the packets. But again, router cannot forward the broadcast message. So what router will do? This broadcast message router will generate a unicast. And source IP 10.1.1.1. From here, it will generate a unicast for server. Server will reply with a unicast, then router will generate a broadcast here. Is that clear? Okay. This is your DHCP relay agent, where your router in between will be acting as a relay agent, responsible for helping the clients to get IP address from a server which is not available in the same network. Yeah. Okay. Now, sometimes what can happen in the organization? Okay. Let me. Sometimes some employees are not happy in the organization. Okay. Frustrated employees can be there. So next concept we need to study here is about DHCP snooping. Again, this is also more of a theoretical concept. Now, what is DHCP snooping? Right now, these clients are getting IP address from where? Your legitimate DHCP server. And they are having a correct gateway IP 10.1.1.1. So if they try to ping with the server, they will be able to ping. They are able to communicate with the server. But sometimes, let's say one of the employee in the company is not really happy. So he might try to bring down the network. So what he'll do in his system, he will install a server operating system. In his machine, he will install a server operating system. And this is an unauthorized server. So I'll call it rock server. Okay. And what this guy will do, he will connect this system to the network. Done. And what he's going to do, he is going to take an IP address from your DHCP server. So he will come to know about your IP range, your subnet mask, your default gateway, everything what you're using, right? And to bring down the network, see how easy it is to bring down the network. If I change the gateway, nobody will have communication. So all I need to change is what? Gateway. So I'll go here. In my server, I'll go and configure a DHCP server. Again, gateway IP, I will set something else, which is not available or which is my own IP address. So that either they will not communicate with anywhere, and if they're communicating, then their traffic will pass through my system. Both the things I can do. If I'm giving a random IP, which is not available, they will not have communication. If I'm giving gateway IP as my system IP, then their traffic will come to me, right? So I have given right now random IP address. Then DNS, I will give the same so that if somebody is trying to troubleshoot also, they will not come to know. Similar kind of DHCP I will create. Save it. Turn on. Now see what will happen. Right now, this guy is having IP address from the correct DHCP. His gateway is okay. And when he tries to communicate with the server, he is able to communicate. Correct? But now, if his system is trying to renew the address or next day he is coming and his system is trying to take an IP address, check the gateway IP. 10.1.1.11. Why? Because your client will always receive the first DHCP offer it receives. Client will always accept the first DHCP offer it receives. So what will happen here? Now this guy has received an IP address and he is going to go and check. Okay, let me try to communicate with the server. No communication. Why? Because 11 IP gateway not available. Network is down. Why? Because in organizations, all your systems, they are authenticated from an AD server. And if you are not able to communicate with your AD, you cannot even log into the system. So if you cannot log in, there is no work that day, holiday, right? So now as a network admin, this is your task to avoid these kind of scenarios. You cannot wait for these things to happen. Okay, you have to avoid it so that even if somebody is trying to do like this, already you have configured a security in place so that they will automatically not allow the fake DHCP server or log DHCP servers. Clear? And that concept, that security is known as what? Snooping. Okay. So understand here. So your DHCP snooping. It is used to avoid log DHCP over attacks in the networks. Okay. So this is a layer 2 security feature. Okay. How do you configure it? So you'll just go to your switch. In your switch, you will say IP DHCP snooping to enable DHCP snooping in your switch. Okay, this is a layer 2 security feature. You will configure it in the switch. Then whatever the VLAN you are using, in that VLAN also, you will configure it. VLAN, and here you will give the VLAN ID. Done. As soon as you configure DHCP snooping, all the ports of your switch, they will become untrusted. All the ports, they will become untrusted. That means through any port which will not allow a DHCP offer. So that means now clients will not get the IP address, even from the legitimate DHCP. Now, whatever the correct port is there, whatever the legitimate port is there, that port you have to make it as trusted. So in our case, F0 by 1. This is the port from where actual DHCP offer will be coming, right? So you'll say interface and your trusted interface name. And then you'll say IP DHCP open trust. This is all the configuration you have to do. Then the IP yes, exactly. That means your switch will allow DHCP offer from this only. If this guy is sending an offer, and definitely this guy will be sending an offer, but here switch will drop it because this is an untrusted port. Clear? So let's go and see this thing. So right now here you can see that PC1 already got the IP from this, and even PC2 will try also. PC2 will also get the IP from this ROG server 11 gateway, right? So let's go and configure our security. Go to the switch. So IP DHCP snooping, and right now default VLAN we are using IP DHCP snooping VLAN 1. Now, if you will try, so these guys, they will not get IP address from anywhere because all the ports, they became untrusted, and this will get the APIPA IP address. Getting APIPA. Why? Because both the DHCP offer your switch is discarding. Okay. And you just go and make one port as a trusted interface F0 by 1, which is my legitimate port. I'll say IP DHCP snooping trust. And now this one port is trusted and all other ports untrusted. Go static, go DHCP, correct gateway. And since you have correct gateway now, you have communication, right? So now doesn't matter how many offers he is sending, but no offer will be forwarded to the client. Static, DHCP, correct gateway. Clear? Online people? Clear, right?
Yes, sir.
Okay. So this was your DHCP snooping. Now in DHCP snooping, what happens? That your DHCP snooping, it creates a database. See, switch does not understand IP address, but in switch there is a table which is DHCP snooping binding table. Okay, DHCP snooping binding database. This is a database where switch has entries about to what MAC address, what IP address has been assigned. Whenever DHCP server will assign an IP address, which will record this thing that okay, to this MAC address we have assigned this IP address. This kind of information will be there. Okay. Now, why I'm telling you this? Because it will be required in the next concept. There is a security feature on the switch which depends on DHCP snooping, about DHCP snooping binding database. And how it depends, let's understand. So the next concept we have is about dynamic ARP inspection. This is also a layer 2 security feature. Now in dynamic ARP inspection, what happens? Consider one example here. You have a PC, you have another PC here, and in between you have a switch. Okay. This is PC1. It has the MAC address M1. And this is PC2. Has the MAC address M2. And this is switch. This is F0 by 1. This is F0 by 2. Okay. Now we know that these PCs, they maintain the ARP cache in which they will have mapping about IP and MAC address. So when they will have communication, your PCs, they will create what? The ARP cache. In the ARP cache, they will have entries about that this IP address has this MAC address. This kind of mapping they will have. Okay. So let's say your PC1 will have an entry in this 10 dot, consider here 10.1.1.1, 10.1.1.2. That 10.1.1.2 has the MAC address empty. Okay. And this is 10.1.1.1. And this is 10.1.1.2. Okay. This is the ARP cache of PC1, and PC2 will also keep an ARP cache in which it will say 10.1.1.1 has the MAC address M1. Right. Now what? When they will communicate, there won't be any issue, which will be forwarding the packets based on destination MAC address without any problem. Okay. Now the problem will be when there will be a hacker in your name. So initially your switch will also maintain the CAM table. And if I talk about the CAM table of the switch, how the switch will maintain. In the CAM table, switch will maintain the entry that okay, on which port, what MAC is connected. So initially switch will have information about PC1 and PC2 only. So switch will say, okay, on F0 by 1, MAC address, M1 is connected. On F0 by 2, MAC address, M2 is connected. Right? Now we are considering that there is a hacker who's connected to your network. Okay. He is connected to a switch. And the switch port will be F0 by 3. So when this hacker guy, he will communicate, he has the MAC address M3 and the IP address he has is, let's say he has received your IP from the DHCP itself, same like these two PCs. Okay. So when he will try to communicate, switch will record his MAC address also, that okay, on F0 by 3 interface, M3 is connected. Now what this hacker guy will do, he will send a ARP this side. He will send a ARP this side. And in the ARP message, this hacker is going to say that my IP address is 10.1.1.2 and my MAC address is M3. This is what the hacker will say. He will modify. Why he will modify? Understand here. So he will send this kind of fake ARP. This is not a real ARP, this is a fake ARP. So he will send a malicious ARP and this guy will receive the ARP message and he will think, okay, 10.1.1.2, he is not available now at M2. This guy is available at M3. Same way, the hacker will send one more ARP on the other side, this side. And even this side, the hacker will say, my IP address is 10.1.1.1, but my MAC address is M3. This guy will receive it, will modify the ARP cache. And this scenario, we call it as a ARP cache poisoning. Okay. And this will be M3. Done. Now when PC1 wants to communicate with PC2, so what PC1 will do, PC1 will generate a message. PC1 will say source IP, destination IP, source MAC, destination MAC. Okay. This kind of message they will generate. So it will say 10.1 is the source IP, 10.2 is the destination IP, source MAC address will be M1, and for destination MAC address, it will check the ARP cache. And what will be the destination? M3. Now this message, it will forward it to the switch. Switch will check what is the destination MAC? M3. Where M3 is connected? 0 by 3. That means switch will forward this message to the hacker. Switch checks the MAC address. Switch does not understand IP addresses. So that means this traffic what the guys sent for PC2 came to the hacker. What the hacker will do? Hacker will send one copy of the information to this guy also. So that if he will receive the information, he will reply. So hacker wants to come and capture entire information. Request also, reply also. Request already captured. If the hacker wants, hacker can modify this information. If hacker wants, hacker can just send a direct copy also. Totally fine. Okay. So let's say hacker has sent the information here also. Now this guy will reply. From here, this guy will reply. He will say source IP, destination IP. Source IP will be 10.2. Destination IP 10.1 because the message came from 10.1. Source MAC address, it will give its own MAC address. Destination MAC address for 10.1, what is the MAC address? It will check in the ARP cache. And the MAC address is M3. This message will come to the switch, which will check what is the destination MAC? M3. Where it is connected? F0 by 3, which will forward it to the hacker. And again, hacker, if they want, he can modify or send one copy here. So what is happening? your entire communication is going via hacker system. Okay. And this way hacker can capture usernames, passwords, credit card numbers, whatever it is. Okay. So you want to avoid this kind of attack also in the network. Okay. Now why this attack happened? This attack happened because of the app the hacker sent, right? If this app was not there, there would be no poisoning of the app cache. If no poisoning, these would directly communicate. The traffic would never come to the hacker. Okay. So this is where your DHCP snooping binding database is useful. Why? In the DHCP snooping binding database. Okay. See here. Now on this switch, you have already configured DHCP snooping. And when you configure DHCP snooping, after that, your clients and everybody will be getting IP address from legitimate DHCP server. So when IP addresses will be assigned from the legitimate DHCP server, what your DHCP snooping will do? It will populate this table. In this table, it will say that, okay, MAC address M1 is assigned with 10111. MAC address M2 is assigned with M3 is assigned with 10113. Okay. Now what you will do, you will configure dynamic app inspection here. So your dynamic app inspection. This attack, what you saw, it is known as man in the middle attack. Man in the attack of cache poisoning. Okay. So now how the app cache poisoning will be stopped. You will configure your dynamic app inspection. Now dynamic app inspection will do what? It will inspect the ARP messages. Okay. And it will take help of this DHCP snooping binding database. Okay. So whatever the app you will send, as soon as you configure dynamic app inspection, all your switch ports, they will become untrusted. Same way. Everybody became untrusted. That means switch will inspect every single port's ARP message. Anybody sending ARP message through any port, switch will inspect. Like this message it was sent. It is saying that my IP address is 10.1.1.2 and my MAC address is M3. Switch will verify and tally this information using this database. That okay, if your MAC address is M3, your IP address was supposed to be 10.1.1.3. Or if your IP address is 10.1.1.2, your MAC address was supposed to be M2. Is the information matching here? No. Drop this out. Which will block these ARP messages. If these ARP messages will be blocked, there will be no poisoning and no man in the middle. This is clear. Now, how do you configure? Okay, how do you configure it? Configuration is very simple and very similar to your same DHCP snooping kind of configuration we have. Okay, you'll go to the switch, you will see IP, ARP, inspection, VLAN, and you'll give your VLAN ID. One line command, all the ports untrusted. Okay, now if there are certain ports from where you want your switch not to inspect, let's say you want that, okay, these are legitimate ports F0 by 1 and 2. So the ARP messages coming from here, the switch should not inspect them. Otherwise, switch will do what? If there is no entry, switch will drop it. So these are legitimate ports. So these ports, what you want? You want to make them trusted. So same thing you will do. Interface and interface name, which is your trusted interface. And you'll see here IP of inspection This is how you'll make it trusted. Okay. So this simulation of this attack in packet tracer, it is not possible. Okay. So directly I'll show you the configuration. That's how you'll configure the command. No, range also you can take, but again you must make sure that okay, your unused port should not be there. Otherwise, to unused port, anybody will connect and will perform this kind of attack. Configuration. Cam table of your switch. These are the up dash. Yeah. So now let's go and show you the configuration. So in the same switch, I'll go and do enable configuration terminal. So I'll say IP off inspection VLAN and let's say VLAN 1. And then whatever the interface you want to make it as a trusted F0/1. I'll say IP off inspection. Okay. These are like configuration wise, these are small concepts, but understanding wise and their action type, they are very important concepts. Theoretical, that's why I'm explaining this much theory. Otherwise, definitely they will. It is there in your syllabus. And see, in your resume, you should mention these things. You should highlight these things that you know layer 2 security also. But before mastering, do not write them. If you do not master the concept and you write everything, there is a problem. Okay, like most people, what they'll do, they will learn about routing switching. In the routing switching, in the routing they'll understand about BGP, and they will mention in the resume BGP, even though they have not mastered it. And when the interviewers they will see BGP, they will ask most of the questions from BGP itself. Why? Very vast protocol. Okay, so master the technology, then only mention it. And do not make a mistake that in resumes most people will do basic knowledge of BGP. There is no basic thing. Okay, you are going for a network engineer role, you cannot say basic. Okay, so master the technology, write them with confidence and answer with confidence. Okay, CCNP is there. In your CCNP routing, it will be there. 2 to 3 days only BGP, one protocol. So this is done. Okay, now let's go for a story. Okay, concept is important, but kind of a story. Concept is port security. Again, this is also layer 2 security feature. So in layer 2 security, you mostly talk about DHCP snooping, dynamic app inspection, and port security. These three are important concepts. Okay. So first of all, port security. So what is port security? It is used to secure switch ports. Okay, you want to secure your switch ports from unauthorized access. Or you can configure port security to prevent unauthorized access to your network. Okay. Now, port security is kind of a rule. And for port security, if there is a violation, there are few violation modes. So first, directly, let's go with the violation mode itself. Okay. security violation. There are three modes in the port security. Number one is shutdown. Okay. So this shutdown mode, this is the default mode. By default, shutdown mode is there. And in this mode, if there is a violation of the port will move to error disable state. Remember it? In the HTTP we have PPD guard. It will move to the error disable state. And in error disable state, what happens? Port will move to shutdown state. Even if you give no shutdown command, it will not come up. Manually, you have to shut down, then you have to bring it up. Okay. So the port will move to the error disable state. Okay. And once it is in the error disable state, even your authorized PC will not have communication. Even authorized PC will not have communication if the port is in error disable state. Okay. This is clear. Then after, in this mode, logs will be generated. Remember we saw logs in the BPD guard that a BPD was received on the BPD enabled port, right? BPD guard enabled port, like that. So here logs will be generated. And here the admin has to manually shut down the port and bring it up using no shutdown. Automatically the port will not come up. This is clear. Now, this was the first mode. This is the first mode. Second mode is restrict. In restrict mode, what happens? If there is a violation, port will not go to shutdown or error disable state, like BPD filter. That your port will not go down. But also, unauthorized PC will not have communication. Even your unauthorized PC will not have communication. Authorized PC will have the communication. Okay, and here logs will be generated. Okay. Then we have the third mode, which is exactly similar to your the third mode is exactly similar to your restrict mode. Only difference, in restrict logs are generated. In the third mode, which is protect mode, logs are not generated. Okay. So if there is a violation, port will not go to shutdown or error disable state. Okay. Authorized PC will not for communication. And logs will not be generated. These are the violation modes. Now let's understand about port security. Okay. So the first thing you can do to secure your switch port, what is the easiest thing you can do? Whatever your unused ports are there, manually shut down. Whatever the ports are not in use, shut down them so that anybody will not be able to connect. Okay. Otherwise, normally what happens? See here. I'll take a switch. Now this is my switch. Okay, with this switch, and let's say I have connected one PC here, or consider it server. Okay, this is my company server. Now this is my authorized PC. Okay, this is my authorized PC, and one more PC I'm taking, which is unauthorized PC. Okay. This is my server. This is my switch. Now my authorized PC is connected here. Authorized PC is having the IP, let's say 10.1.1.1, and let's say server is having IP 10.1.1.1. Okay. Or else what you can do in server, you can consider there is a DHCP server and all. So these guys, they will be automatically getting an IP address also. So let me use that same scenario. Okay, let's say this guy will get the IP address from DHCP. So we'll configure one DHCP server here. 10.1.1.100. Let's use the default subnet mask. Gateway DNS, these I'll not use. And 10.1.1, say, starting from 1 itself. Okay, and service is on. Now my authorized PC will take an IP address from the DHCP. Received. Okay. And he is able to communicate. Authorized PC will be able to communicate with the server. Correct? Same way, if my ports are not down, this guy can also connect. If he finds a port, he can also connect. And to save this time, let me just go and configure port pass so that we don't have to wait 50 seconds. So interface range I have 0 by 1 to 24, spanning tree port pass. Okay, just so that we don't have to go and wait for it. Now go here, desktop IP configuration. He will also take a IP address from DHCP, and now he is also able to communicate. Now this is unauthorized PC, not supposed to communicate. So what we want that, okay, nobody should be able to connect to any unused ports. So I'll go to my switch. Okay. And in my switch, whatever the unused ports, see here. Let me disconnect him. So my port number 1 and 24 is in use right now. 2 to 23 not in use. So all those ports, I'll say interface range F0 by 2 to 23, and I'll give the shutdown command. Once I have given manually the shutdown command, now if this guy will even try to connect, he will not be able to communicate. Doesn't matter, he will try 2, 3, 4, 5, whatever the port, all ports, he will not have communication. Clear? This is the first thing I can do to secure my switch ports. Okay. So the first thing we can do here, shut down the unused port. Okay, so what do you do? You'll say interface range and a range of interfaces. And it is not mandatory. You can use a dedicated single interface also, depending on how many interfaces are there. And you will give the shutdown.
If I want to use the VLAN of the interface, I can use
No shutdown. Dedicatedly, you can go and give the no shutdown. But okay, now what I did, I have said that okay, all the ports are down. Now this is one employee who is really desperate to use the internet of the company. Why? Because I have very good internet connection in my company. He want to download movies, he want to download games, right? So what he will do, he will think that okay, I'm not able to use my personal system. So what he will think that okay, I'll bring extra switch. I'll bring the extra switch. Then what I'll do? Okay, correct? Done. Now see here. Let's try to communicate. Having communication, this is authorized PC. This is unauthorized PC. Now you can say that, okay, we will enable BPDU guard here. So as soon as this switch will send BPDU, the port will be in the down state. This thing you can say, or you can say, I will enable BPDU filter. So this switch will not have any communication. So what if he will connect a Wi-Fi access point? Wi-Fi routers are also there. He will start a Wi-Fi connection and he will also use his phone also, right? So what we'll do, we will enable on this port. This is the port of our switch. Wherever you will connect end host, you will configure port fast, BPDU guard, BPDU filter, okay? Other than that, you will also configure port security. So once you enable port security, what will happen? By default, only one MAC address will be allowed through this port. So if only one MAC address will be allowed, when this guy will try to communicate using this switch and all, so there will be more than one MAC address. And immediately this port will go to the downstate. Okay. So see here. Right now, if I go on this switch and if I check what is the status of my port security on the interface F0/1. So in show port security interface F0/1. So right now my port security is disabled and my port is in, like my port status is secure down. That means port security is not enabled basically. Okay. So once I will configure it, this should be enabled. Okay. So how you will configure the port security? This is the second thing we will do. Enable port security to allow only one MAC address. How will you configure port security? Just go to the interface name. Okay. And by default, DTP is enabled. Your ports are in dynamic auto mode. So on DTP enabled ports, you cannot configure port security. Your comments will get rejected. So first of all, you will give switch port mode access to make it permanent access. Now you can say switch port security. This will enable the port security. Okay. And I will show you directly also if I try to give what happens. So interface F0/1. I'll say switch port security. Directly I try to configure it without bringing it to the access. Says what? Command rejected. Why? Fast Ethernet is a dynamic port. So first of all, you have to say switch port mode access. Then you can say switch port security and it will be enabled. Once it is enabled, do show port security interface F0/1. And port security is up. By default, what is the violation mode? Shutdown. That means if there is a violation, port will go to the down state. What are the total MAC addresses allowed? Only one. Okay. See here, when this guy will, even he will use authorized PC also this time. You see your port turned into down. Okay. So your port will go to the down state here. Clear? Now, if I go to this port and if I say no shutdown command also, again, my port will not come up. Why? Error disable state. So we have to say shutdown, then we have to say no shutdown. Now this guy says, okay, I cannot use the switch also. Problem, right? Okay. That means the switch is not useful. Okay. So this guy, the switch is not useful, but still he want to download the movies. Okay. So what this guy will do, he'll say that, okay, during my lunch time or for some time, I'll do what? I'll directly connect this cable here. Only one MAC address is allowed. At a time, any one MAC address can be there. And this guy will have communication. See how desperate the guy is. Okay. Just a second. MAC addresses. Let me check the IP configuration. Okay, PIPA it has taken. See. Now again, he is able to use the network. Again, we want he should not be able to use. Hmm? Yeah. So we are saying at a time one MAC address. I said what I said here. See here. To allow only one MAC address. I did not configure any MAC address here. Correct? And that's why he is able to use. So now what we'll do, we'll say that on this switch port, I will configure that only my authorized PC should be able to communicate. Nobody else should be able to communicate. Okay. So what I'll do, I'll take the MAC address of this PC now. Okay. I'll go to config, fast Ethernet. I'll take the MAC address of this PC. Copy. Then I'll go to the switch. Interface. F0 by 1. You will say what? Switch port mode access to make it a access port. Then to enable port security, you'll say switch port security. Then you will say switch port security, MAC address, and you will paste the MAC address, whatever the MAC address you want to configure. And right now it has already captured this MAC address, so it will not allow it. So for a reason, just for right now, what I'll do, I'll change the MAC address here. I'll make it easy. Okay. This MAC address I'll copy. Now see what will happen. Say switch port total secure MAC address on the interface path Ethernet has been reached. Okay. Default interface F01. Okay, now let's configure it then. Interface F0 by 1. Switch port, mode access. Switch port security. Switch port security. MAC address and this. Done. Okay. Now this MAC address has been configured on the port. Now if this guy will try to communicate, he will not have communication. You see port went to the down state. Okay, that means there is a violation. So let me do one thing. Also, let me change that violation mode. Okay. So how do you change the violation mode? You will say switch port security, violation, and this time I'll give it restrict mode. Okay. So you manually shut down the port and bring it up. Now you'll see that what will happen. He will not have communication even though the port is up. Why? Because this time the violation mode is restrict. restrict mode, your unauthorized PC will not have the communication and authorized PC will have the communication. See here, I'll connect it here. This guy will take up an IP address. Okay, this guy will take an IP address from the DHCP already there. So he will have communication. Is that clear? So what did we configure here? We just bind the port with host. Bind port with host using MAC address. Okay. And according to fresh configuration, these comments will be there. And one extra comment about the MAC address. Switch port, port security, MAC address, and here you will configure the MAC. Is that clear? Now you have configured the MAC address. Okay, but if it is one system, you can copy and configure the MAC address. Two system, but what if 5,000 systems? Solve. Okay. So in that case, what we can do, we can use a dynamic method of binding the port. Okay. What is that dynamic method? You will say bind ports with ports dynamically using MAC address or using the sticky command. There is a command that is sticky. Okay, it's not really very different. Everything is same. Just you don't have to use the MAC address. Instead of MAC address, you will write a word sticky. This is it. So what the sticky command will do, it will take the first MAC address that will communicate through that port. Okay. It will capture the first MAC address that will communicate through the port. So these things, port security and everything, you will configure when you are initially designing the networks. So when first time there will be communication, it will be your legitimate PC only. So it will automatically capture the MAC addresses. The MAC addresses that will be dynamically captured, it will be in the RAM. Then after you will save that configuration using the write command. So configuration will be saved in the NVRAM. Then it becomes the permanent configuration. Is that clear? So anytime a system is changing, you will just go and change the MAC address of that dedicated interface and you're good to go. Okay.
So honestly, you cannot
Yeah,
accept that because already told you.
already stored. Yes. So here, this time what I'll do, I'll take few more systems. Okay, this time we want to use the sticky command. Let me just say something like so that I don't have to change the name. Okay, let's say these three pieces. So they will connect to port number 2, 3, and 4. Okay. So first of all, I'll bring up the port 2, 3, and 4 because by default they are in the, not by default, I have manually shut down the port. Interface range as 0 by 2 to 4. Okay. Now what? Let's go and configure these three interfaces. So with the sticky, what is the benefit? You don't have to configure a single interface. You can configure a range of interfaces because you are not typing a specific MAC address. So again, you can use the command interface range of 0 to 4. You can say switchboard mode access, switchboard port security. Then you can say switchboard port security MAC address, sticky, and let's change the violation mode also. Violation protect. Third mode. Right now, if you go and see, do show, not do show, show running config. Right now, you can see there is no MAC addresses after the sticky right now. Right now, there is no MAC address on the port 2, 3, and 4. Okay. But once they will communicate, okay, so they will get an IP address also. Desktop, IP configuration. Okay, they have already taken an IP address. So from this PC, I will try to ping everyone. Okay. So I'll say ping 10.1.1. This is 4, 5, and 6. So let me ping 5. I'm able to ping. What about 6? I'm able to ping. Okay, once these PCs, they will have communication. The switch will record the MAC addresses. Now you can see here. I had some communication. Now if I go and say show running config, you can see that switch has automatically captured the MAC addresses. Okay, now all I need to do is what? Just go and give the right command and this configuration becomes permanent. Now what? These PCs, they will be able to communicate. You can see like PC3. If I try to go and ping the server, I'm able to communicate. But in place of this, if I will connect unauthorized PC, and let me check the IP configuration. So this guy has a IP address. Let him take IP address from the DHCP. Okay, he will not take, because when he will try to send the message, the MAC address will be different. So he will not even get an IP address. So this way, he will not communicate. Unauthorized PC will not communicate, and your authorized PC will be able to communicate. Okay. See here, this guy is not able to communicate, and when you come to this guy, his MAC address is already mentioned there. So first of all, I need to check the IP address here also. Otherwise, this will also take a PIPA. He is taking a PIPA. We need to go start it. See, this is getting the IP address. But the unauthorized PC was not even getting the IP address also. So that means communication system, we have communication. This is your port security. Clear how you can secure your network at layer 2, right? Yes, if somebody is spoofing the MAC address, then you can do anything. If somebody is spoofing the MAC address, then you cannot do anything. Then in the network itself, you have to enable MAC filtering. Okay. But still, this level of security at least you have. Okay. And if somebody wants to use internet, okay, then we can configure MAC filtering also. Or we can block websites. Those are things we can do. Clear? So this was your port security. Any doubts? No? Online people? Guys, clear to everyone? Okay then, that's it for the day. I'll see you guys on Monday.